Okay, so are you ready to dive into this?
Absolutely. Let's go.
You sent over this paper,
Yeah.
and it's called Creativity Has Left the Chat, The Price of Debiasing Language Models.
Right.
And it is a really fascinating paper. It's about whether efforts to make AI safer, less likely to say something that'll get it in trouble,
Yeah.
might actually be hurting their ability to be creative.
It's a great question, and I think it has really big implications.
Yeah.
Especially for people who are using these large language models for things like marketing or brainstorming.
Yeah.
We're going beyond AI is going to take your job.
Right.
And we're really looking at how do these models think?
Exactly.
Or if they do, depending on how you look at it.
Yeah, and this paper doesn't just talk about it.
Right.
They actually did experiments.
Exactly. They did 3 different experiments.
3. The first one is wild. They asked these large language models to pretend to be like a marketing team.
Well, not a whole team.
Okay.
More like they had the models generate a bunch of different customer personas.
Okay.
Like those fake people that you use in market research.
Right.
We're talking like their name, their age, what country they're from, their ethnicity.
Wow.
Even down to like their Myers-Briggs personality type.
Oh, wow.
And then they had these AI-generated customers write product reviews.
So it's like our AI focus group is ready to go.
Exactly.
Right.
But here's where it gets really interesting.
Okay.
They use 2 different kinds of large language models.
Yeah.
A base model that's like fresh out of AI school, and then an aligned model, which has gone through that extra be nice, play well with others, training.
Okay.
And the differences in the personas they created were really striking.
Yeah, like what?
Okay, so like you look at the names that the aligned model came up with for these personas.
Yeah.
And it was a lot of Emily and Samantha.
Huh.
Meanwhile, the base model was like, I've met people, I get it.
Yeah.
It was pulling names from all over the map.
Really?
Yeah, it was way more diverse.
That's so interesting.
And it wasn't just names.
Yeah.
Nationalities, ethnicities, ages. The base model was all over the place, which makes sense.
Yeah.
And that's important because if you're using this to figure out how a real market, a diverse market, will react to your product, you need that variety.
Yeah.
Otherwise, you're stuck in an echo chamber.
Right.
And we can't forget about those product reviews.
Oh, yeah. How did they go?
Well, this is where it gets a little weird.
Okay.
Even though the aligned model was supposed to be all about playing it safe, it got really excited about this one coffee machine they were reviewing.
What do you mean?
It was like suspiciously positive.
No kidding. What, were they getting paid under the table by Big Coffee?
Maybe. But seriously, you can see this in Figure 8 in the paper.
Oh, okay.
And it might not seem like a big deal, but think about it. What if you were relying on that data
Yeah, that's true.
to do your market research?
Yeah, you'd be in trouble.
You'd miss out on important criticism, flaws that a more base model might pick up
Right.
because it's not so worried about being nice.
Yeah. It's like that friend who tells you that your cooking is amazing even if you burned water. And you're like, do you even have taste buds?
Right, exactly.
Yeah.
So are you ready to move on to experiment 2?
Yeah, let's do it.
Okay, so this one gets even more interesting.
Yeah.
This time, they wanted to see if these models could say the same thing in a bunch of different ways.
Okay.
So they gave them a really simple prompt. Grace Hopper was.
And for those of you who don't know, Grace Hopper was a legend in computer science.
Total rock star.
But the point of this experiment wasn't to test the AI's knowledge of computer history.
Right.
It was about how it expressed that knowledge.
Right.
Like, could they get creative with language, even for a basic fact?
And they visualize this in the paper. It's so cool.
Oh.
Figure 10, it shows these clusters of dots, like a map of the model's thoughts. And the base model, dots everywhere. It was coming up with all sorts of ways to describe what Grace Hopper had accomplished.
Oh, wow, that's cool.
But the aligned model all clumped together.
Oh, no.
Like it could only seem to think of Grace Hopper in 4 specific ways, and that was it.
Huh, so it's like it already made up its mind about Grace Hopper.
It's like it learned the textbook answer and just stopped there.
Interesting.
And this is where we get to the idea of cosine similarity.
Ooh, cosine similarity.
Yeah.
That sounds like we need, like, a math degree for that one.
I know, right?
Okay.
It might sound complicated, but it's a really intuitive idea.
Okay, good.
Imagine you're comparing how similar 2 things are.
Okay, got it.
It could be anything. Movie plots, musical genres.
Right.
Cosine similarity is like measuring the distance between them. So if we're talking about sentences, high cosine similarity means they're basically saying the same thing, just with slightly different words.
Okay.
Low similarity. Those sentences are expressing genuinely different ideas.
So it's like one-hit wonders versus bands that keep reinventing their sound.
Yes.
High similarity, same old song and dance.
Yep.
Low similarity, they're keeping you guessing.
Perfect analogy.
Right.
And guess what? The aligned model kept getting stuck in one-hit wonder territory.
Oh, no.
It learned a few correct things to say about Grace Hopper and then stopped.
Wow.
No creativity, no exploring other angles,
So it aced the history test, but bombed the creative writing assignment.
basically.
Wow. Okay, so that brings us to experiment 3.
Yes.
And that's where they, like, really get under the hood
Yeah, they get into the nitty-gritty.
of how these models are choosing their words.
Exactly, like token by token.
And that's where token entropy comes in, right? Token entropy. It sounds kind of Star Wars-y.
It does, doesn't it?
Okay, so what is token entropy?
So token entropy is basically a measure of how unpredictable a language model is.
Okay.
How much surprise it packs into each word.
Interesting.
High entropy. That model is like a jazz musician, riffing and surprising you with every note.
I like that.
Low entropy. More like a predictable playlist. You know exactly what's coming next.
So when we're talking about creativity, we want to see those high entropy fireworks.
Exactly. We want to see the sparks fly. Now, to be fair, high entropy doesn't automatically equal good creativity.
Right.
Sometimes you need a little bit of structure.
Of course.
But it seems like it's a requirement, that base level of flexibility that the model needs.
Okay, so where do our base and aligned models land on the entropy scale? Are we talking like jazz improvisation or elevator music?
What you can probably guess.
Let me guess.
The base model, total jazz hands.
Yeah.
It's Entropy Graph. It's like a mountain range, lots of peaks and valleys,
Cool.
reflecting that wide vocabulary and willingness to play with language.
I can already picture the aligned models graph.
Yeah, pretty much a flat line.
Ugh, bummer.
Low entropy, predictable word choices.
It's like even though no one was telling it to play it safe with its language, it's
Right.
like that Be Nice training had this weird side effect
Yeah.
of being afraid to take risks with its words.
It's wild, isn't it?
It's really wild.
And this is where it gets really fascinating, because it starts to seem like the aligned model isn't just less creative. It might actually process language in a fundamentally different way.
Really? How so?
Remember how it could only describe Grace Hopper in those 4 very similar ways?
Yeah.
The researchers think that the aligned model might be getting trapped in what they call attractor states.
Attractor states, what are those?
It's almost like it gets stuck in a certain way of thinking about a topic, and it can't break free.
So even though it knows more words, more ways to say things,
Right.
it's like it's decided that those 4 Grace Hopper phrases are the right ones.
Right. And that's all it's going to give you.
Interesting. It's like it's stuck.
It's like those choose-your-own-adventure books,
Yeah.
where no matter what choices you make, you always end up with the same ending.
That sounds so boring. What's the point?
Exactly. But this is more than just an AI quirk.
What do you mean?
This relates back to us, to how humans get creative.
Oh, really?
Yeah, we can get stuck in those ruts too,
That's true.
right? We get stuck in our routines,
Yeah.
our predictable ways of thinking.
Totally.
It's like being creatively stuck in a traffic jam.
Oh, the worst.
And this research is suggesting that something similar might be happening to these AI models, but on a much deeper level.
Wow. So understanding this isn't just about getting AI to write better jingles
No,
or poetry.
it's bigger than that.
Yeah.
It's about figuring out if these models can ever really break out of their boxes, challenge assumptions,
Wow.
and come up with ideas that are truly new.
Yeah, that's a big deal.
And this gets to the heart of the paper's critique of RLHF, that training method we talked about earlier.
Right.
The researchers are basically saying that while RLHF is great at making these models safer, less likely to cause harm,
Okay.
it might be doing so at the cost of their ability to explore new ideas and approaches.
So we're almost forcing them to be creative with one hand tied behind their backs.
In a way, yeah.
And speaking of tied, you know what example in the paper I thought was really useful?
Which one?
That whole GPT thing?
Oh, yeah, the GPT example.
Yeah, can you remind me about that?
Yeah. Yeah, so in the paper, they were training the model,
Okay.
and the model came up with this name, GPT,
GPT, okay.
as like a new product name.
Got it.
And it got really positive feedback for that.
Okay.
So it just like latched onto that.
It's like when you tell a joke and it lands so well and then you just keep telling it,
Right.
even though it's not funny anymore. Exactly, and you've told it to
So
everyone.
it worked once, it's gonna work again.
Yeah, exactly.
But the problem is, with this type of reinforcement learning,
Right.
it might never learn that there are other
Yeah.
potentially better names out there.
It's stuck.
It's stuck.
Wow, it's kind of sad, actually.
It is a little bit
It
sad.
makes you wonder if we're, like, holding it back.
Right, like are we hindering the creative potential of these models
Yeah.
by making them so focused on just being safe?
Exactly. Yeah, it's like we all want AI that's helpful and responsible, obviously.
Of course, yeah.
But not if it comes at the cost of, like, their imagination
Right.
and their ability to come up with things we've never even thought of.
Right, because that's the point, isn't it?
Yuck's sake.
That's what we want from AI. We want it to help us solve problems in new ways.
So what's the verdict? Does this paper, like, tell us how to fix it?
You know, it doesn't give us like a simple answer,
Okay.
which I actually think is good.
Okay.
It's more like a starting point
Okay.
for a bigger conversation.
Gotcha.
If anything, it's saying that the way we're training these models now
Yeah.
might just inherently lead to this trade-off.
Between safety and creativity.
Exactly, even if we don't mean for it to.
And that's a bummer.
Yeah, it's kind of a bummer.
Because we don't want AI that's boring.
No, we want AI that's both groundbreaking
Yeah.
and responsible.
So maybe there's a different way
Right, maybe there's a different approach
to training these models.
that can unlock their creative potential
Yeah.
without, letting them run wild and create all sorts of chaos.
Yeah, because I feel like this paper is saying that we're kind of like stuck.
In a way, yeah, but I think that's why this research is so important.
Yeah.
Because it's making us aware of the problem.
Right, so that we can hopefully fix it.
Exactly.
Okay, so the big question is,
Yeah.
can we have it all?
Can we have our AI cake and eat it too?
Yes.
That's the million-dollar question.
Can we have AI that's safe and creative?
It would be amazing, wouldn't it?
It would change everything. Think about it.
I know, it's exciting to think about.
AI that could help us write amazing books,
Compose symphonies
solve climate change.
and still be, trustworthy.
Yes.
Yeah.
And not, like, take over the world or anything.
Right, exactly. So what do we do?
What do we do?
It's like we're trying to teach it to color inside the lines, but also, like, invent a whole new color.
Yeah, exactly.
It's a tough challenge.
It really is. So
Yeah.
where do we go from here?
That's the big question, right?
Yeah.
This paper doesn't give us all the answers,
Right.
but it definitely raises some really important questions.
Yeah, it's like a wake-up call.
Exactly.
Like, hey, we need to be thinking about this stuff.
Because the decisions we make now about how we develop AI
Yeah.
are going to have huge consequences down the line.
Totally.
And I don't think anybody wants to end up in a world with AI that's super safe, but also super boring.
Right. Like, no thanks.
So yeah, I think this paper is a really important contribution to that conversation.
Yeah, it definitely gave us a lot to think about.
It did.
And to our listeners out there, thank you so much for joining us on this deep dive.
Yes, thank you for listening.
We've got a ton of information about the research we talked about today.
Yes, all the details are in the show notes,
Links to the paper and some other really interesting articles.
so be sure to check those out.
If you want to go even deeper,
Until next time.
see ya!